everyone, myself Mr. Sunil Kumar Singh, graduated from BIT Sindri Dhanbad in 1994 in mining engineering and MTech from IIT BHU in 2000. I am presently working as Head of Department Mining Engineering at Bilaspur College of Polytechnic, Bilaspur. I have total 20 years of experience in teaching of mining field. Now, I am here to present on heat and humidity in underground mines. Heat is an integral part of all mining activities. Not only activities, but different conditions are also responsible for emission of heat in an underground as well as open cast mines. In open cast mine, the heat produced is dissipated in the environment, not creating much problem to the working conditions, unlike in underground mines where proper ventilation provisions are made to eliminate the produced heat to improve the working conditions for miners. In underground mine, particularly deeper one, provides a considerable and profound source of water as well as heat. Besides, this water is also used for well drilling as well as dust suppression. There are two causes: prime source of moisture in mines as the area is confined and less number of open passages. In open cast mines, the area is large, but in underground mines, the area is confined. So, there is no any escape route for the dissipation of heat from the underground mines to the surface in direct way. That is why these heats gets accumulated inside the mines. This is also similar for humidity, particularly in deeper mines where groundwater is accumulating, and this groundwater after evaporation gets form water vapor and which mixes with air causing humidity. Some terminology associated with heat and humidity. Heat flux. Heat flux is defined as the amount of heat transferred per unit area per unit time from or to a surface. In practice, the heat flux is measured by the change in temperature brought about by its effect on a sensor of known area. Its SI unit is watt per meter square. Basically, this is the heat radiated from a hot body in surrounding. Now come to sensible heat. The heat causes rise in temperature is sensible heat. This heat is felt by us when we move in hot place, and this heat is directly measured with the determination of temperature by an ordinary thermometer. And come to latent heat. This heat does not cause rise in temperature, but it is responsible for state change, and rise in humidity is latent heat. It has a fixed value, and just like any state change means a state change from solid to liquid or liquid to gas, etc. And reverse is also true, that is from liquid to solid or from gas to liquid. This is the latent heat. It is not generally felt by us. Virgin rock temperature. It is also called natural temperature. This is the temperature of rock at a particular depth, at a particular place, or in a particular locality. The temperature of a depth at a temperature of rock at a particular depth below Earth's surface, because of the geothermal energy stored in it, is called virgin rock temperature. It is particularly term associated with the temperature of rock at certain depth. It is not the temperature of the rock which is present above the surface of the earth. Now come to dry bulb temperature. It is the temperature of air recorded by ordinary thermometer when it is not affected by moisture present in the air. Dry bulb means here the bulb of a thermometer is kept dry and open. The air in which we live, its temperature can be determined using thermometer, which is called dry bulb temperature. Now come to wet bulb temperature. Wet bulb temperature is the temperature of air recorded by a thermometer when its bulb is surrounded by a wet cloth exposed to the air. In this situation, we keep a muslin cloth over the bulb of the thermometer, and this thermometer is brought in normal atmosphere where the evaporation takes place and the temperature of thermometer decreases. Once a situation is reached where the temperature becomes constant because the surrounding earth becomes saturated with moisture, and this temperature is wet bulb temperature, and wet bulb temperature is less than dry bulb temperature. Now come to dew point temperature. It is the temperature of air recorded by a thermometer when the moisture present in it begins to condense. This means the surrounding temperature of air is brought below the wet bulb temperature, that is, the temperature of saturated air becomes low, then moisture given off from the atmosphere, that temperature is dew point temperature. At a particular place at a one time, this temperature generally fixed for unsaturated air. Dry bulb temperature is highest and dew point temperature is lowest, and wet bulb temperature varies between dry bulb temperature and dew point temperature. Now, a specific humidity or moisture content. It is the mass of water vapor present in 1 kg of dry air in the air vapor mixture and is generally expressed in gram per kg of dry air. It is basically the moisture content of the normal atmosphere in which there is some water vapor already present in vapor form, and the mass of water vapor is expressed in gram, and its sample is taken in laboratory and heated, and after some time the air is again weighed and the mass of moisture is calculated, and then we calculate the specific humidity or moisture content of air. Now come to relative humidity. Relative humidity, it is the ratio of actual mass of water vapor in a given volume of moist air to the mass of water vapor in the same volume of saturated air at the same temperature and pressure. It is the basically ratio, and it is expressed in percentage. If relative humidity is very high, it means in the atmosphere the mass or quantity of humidity is very high, because it is just the ratio of mass of moisture or water vapor in unsaturated air divided by mass of water vapor in saturated air. Again, enthalpy. Enthalpy is the measurement of energy at a thermodynamic system. The quantity of enthalpy means heat or energy equals to the total content of heat of a system. This is the equivalent to internal energy plus the product of volume and pressure. This term comes from the second law of thermodynamics, or enthalpy is another form of energy. Sources of heat. The following are the major sources of heat in mines. First of all, we come to surface mines. In surface mines, it is the natural sunlight and sources of it is working machines, blasting, spontaneous heating, particularly in coal mines where the coal catches fire automatically, and human metabolism from human. Sources of heat in underground mines. It is first of all auto compression, strata heat, blasting, light, machines, oxidation and human metabolism. It is represented by a diagram. You can see in the middle, in the center it is the sources of heat, and the periphery, these are the various parameters that causes the sources of heat in underground mines and in surface mines. Now, in detail, sources of heat. Auto compression. When air descends in downcast shaft, it gets heated due to increase in temperature by auto compression, as the formula T2 by T1 equal to P2 by P1 to the power gamma minus 1 divided by gamma. T is the absolute dry bulb temperature, P is the barometric pressure, gamma is the adiabatic constant, 1 and 2 denotes the shaft top and shaft bottom conditions respectively. The increase in temperature of air is T2 minus T1. Clearly, the compression of air that takes place in downcast shaft causes the heating or increase in temperature of descending air. So, T2 greater than T1 because P2 becomes greater than P1 due to compression, the pressure increases and hence temperature also increases. Strata heat. It has been observed from the core of the earth that heat flows radially outward at a rate of 0.05 watt per meter square. Thus, when we go down deep inside the earth, the temperature of strata increases, and the rate of increase of strata with depth is called geothermal gradient. It varies from place to place, and due to geothermal gradient, the strata temperature increases, hence heat increases. This means due to geothermal gradient, as we go deeper down the earth towards the core or center of the earth, the temperature of rock gets increases at a constant rate at a particular place. For Indian coal fields, it is 1 degree Kelvin or 1 degree centigrade per 39.4 meter. It means whenever we go every 39.4 meter down the earth, its temperature gets increased by 1 degree centigrade. And in deeper underground mines, if it is at 1000 meter depth, if the surface temperature is 25 degree centigrade, then its temperature at the bottommost part of the mines will be more than 40 degree centigrade, and which is very high for working. Now, another term is oxidation. This is the very important sources of heat because it takes place continuously. The coal sulphide ore mines are particularly liable to suffer from a heat load arising from oxidation of fractured rock. Each 1 kilogram of oxygen consumed oxides 12 by 32 kg of carbon, gives a corresponding heat production of 12 by 32 into Cc. Cc means calorific value of carbon, that is 33,800 kilojoule per kg, thus producing 12,675 kilojoule of heat in consuming 1 kilogram of oxygen. Similarly, 1 kilogram of oxygen strata heat, it is the heat absorbed that from the core of the earth, heat flows radially outwards at the rate of 0.05 watt per meter square. This is the geothermal heat, and according to this geothermal gradient is calculated. Now comes to oxidation. Heat due to oxidation is very important because it provides large amount of heat due to higher value of calorific value of carbon. 1 kilogram of oxygen will produce 9304 kilojoule of heat during the oxidation of 1 kilogram of sulfur. So, heat produced due to oxidation of coal is very high, and this heat cannot be neglected in anyhow. This is the value of Qc equal to Qa QoI minus QoR into rho O into 12675 kilowatt. Qa is the quantity of air entering the district of an underground mine in meter cube per second. QoI is the amount of oxygen in air entering the district in percentage. QoR is the amount of oxygen in air leaving the district in percentage. Rho O is the density of oxygen in kg per meter cube, and multiplying this we calculate the mass rate of flow of oxygen in the panel or district of an underground mine. And mass into 12,675 kilojoule per kg calculated, we get this heat in kilowatt. Similarly, in case of sulfur, it is 9304 multiplied by the mass of oxygen, and it is also calculated in kilowatt. Basically, such heat is very important in terms of that the oxidation of coal, timber is continuously taking place throughout the operation of the mines, and oxidation process is always exothermic in nature. However, maximum amount of this heat is carried out by the ventilating air, but some amount may get trapped in the air and causing the air to get heated. Now, heat transfer from explosive and blasting, this is also a major source, but it has been estimated that 90 to 95% of this heat released during the blasting get transferred into mine atmosphere, and which is carried out by ventilating air to the surface, and thus about 5 to 10% of heat produced during the blasting of explosive remains trapped in the air, and heat released by blasting can be calculated by the formula E into QE by 864,000 into kilowatt, means E is the calorific value of explosive after blasting in kilojoule per kg, and QE is the amount of explosive consumed per day in an underground mine. In an underground mine, there may be 4 to 5 rounds of blasting in 24 hours in a panel. That is why the total mass of explosive consumed during blasting can be calculated, and its calorific value is known. Then we divide it by 86,400 because in 24 hours there is 86,400 seconds. So, to calculate the energy in kilowatt, we use such terms. Heat transfer from diesel equipment. Generally, underground coal mines does not use diesel engine because of its harmful emission gases. The gases emission from exhaust of diesel engine contains some flammable and explosive gases that is prohibited for underground coal mines, but in underground metal mines some diesel engines for loading, drilling or transportation purpose, these machineries are used, and these machinery consumes diesel engine, and diesel engine has very low efficiency means it is 30 to 40%. So, the remaining energy is transferred into heat energy, and this heat energy gets mixed with air and causing it to heat. Diesel engine is a prime source of heat in underground metal mines if it is used on a vast level or a maximum time. Heat transfer due to human metabolism. When a number of people or workers in an underground mine environment is large, the temperature gets increased due to human metabolism. Here, human metabolism means respiration, sweating, and respiration is exothermic process. So, at one place, if number of people, a number of workers is more, then combined respiratory heat produced during inhalation and exhalation of air by the persons during hard work, the amount of heat produced cannot be ignored, and it is of considerable amount, and this heat when mixed with air causes later warm. Again, heat transfer from underground water. The underground water transfer heat to the mine air mainly by evaporation, because in the deeper, as we go down deeper, there is presence of water. This groundwater comes through the strata by exudation, by percolation, and they get accumulated or even flow through the roadway of the mines. These water, when get evaporated with mine air, gives rise to moisture content of air, as well as the temperature of air also gets increased. Now come to humidity. Mine air is a mixture of dry air and water vapor, particularly in underground mines where there is a confined place. The air present in that part also contains moisture, and which amount is not ignorable. Humidity is quite common for a mining environment, as the mine air at a particular temperature contains certain maximum amount of water vapor. When mine air is fully saturated at a particular temperature, it means that air is not able to pick up more amount of water vapor at that temperature. If the temperature of air is increased, it naturally becomes unsaturated. Conversely, if mine air is cooled, its degree of saturation increases until it reaches to a full saturation at a particular temperature. This particular temperature at which the space is fully saturated is called dew point temperature. Moisture content of air it basically comes from the evaporation of water, particularly in underground water. It is from groundwater, and evaporation process is continuously taking place, and the addition of moisture into air also takes place continuously throughout the working period of the mines. Vapor pressure. Vapor pressure is the measurement of amount of moisture in the air. It is technically the presence of water vapor above a surface of water. When air reaches the saturation vapor pressure, the water vapor in it will condense. At this time, the dew point temperature is the same as the air temperature. The saturation vapor pressure is the pressure of vapor when it is equilibrium with the liquid phase. The vapor pressure is of two types. One is vapor pressure of unsaturated air, that is the actual pressure of vapor. It is the partial pressure of vapor present in air. But another is saturation vapor pressure, which is more than vapor pressure. It is the pressure of water vapor present when the air or surrounding air is fully saturated. Naturally, if vapor pressure reaches its maximum value during saturation of air, the air becomes condensed to form water or dew. Relative humidity. Relative humidity is the ratio or expressed as a percentage of amount of moisture actually in the air to the maximum amount that can be present at that temperature. It is expressed in percentage. Percentage humidity, it is the ratio of mass of moisture per unit mass of dry air to the mass of moisture required to saturate at that temperature. It is different from moisture content because it is the mass of moisture per unit mass of dry air and to the mass of moisture required to saturate air at that temperature. It is the mass of moisture required to saturate. A specific humidity. A specific humidity is the mass of water vapor present in unit mass of air. Similarly, clearly the percentage humidity is the ratio of a specific humidity and the mass of moisture required to saturate at that temperature. The three terminologies are interrelated to each other. Effect of heat and humidity on miners. Naturally, if the underground mines had higher heat of surrounding air, it will seriously affect on the workers who are working in underground mine at a particular place. Now, the various heat effects are, first of all, heat inlays or heat fainting. It may occur as a result of vasodilation, pooling of blood in dependent extremities, reduced blood volume from dehydration, result in reduced cardiac output. It is not associated with an elevated body temperature. Means if the body temperature is high, it causes reduction in blood volume and it affects lungs, alveoli, etc. Next, heat exhaustion. Heat exhaustion is a complex symptom of fatigue, headache, nausea and giddiness. A person who continuously working in high heat condition, he may suffer the problem of dehydration, the loss of water from his body, and there may be chances of headache, he can vomit, that is nausea, and giddiness means there may be darkness inside the mind of a person. Heat exhaustion occurs as a result of either dehydration and or electrolytic depletion, means there may be lack of mineral or salt inside a body of human being and which may cause dehydration and lack of water, and this problem can be solved by drinking sufficient amount of water and removing person from such hot and humid condition to other fresh condition. Heat cramp. Heat cramp is the electrolytic balance of the body fluid is sufficiently disturbed, then painful muscular contraction occur in the arm, leg and abdomen. Means the body fluid gets imbalanced, its composition gets changed, then there may be a muscular contraction occur in the arms, legs and abdomen, and it causes a pain in that area, and workers suffering from such problem cannot work efficiently and they should be remedied. Effects of humidity, effects of high wet bulb temperature. Wet bulb temperature is directly associated with the saturation of air. So, if wet bulb temperature is high, it means air has maximum amount of moisture and the rate of evaporation becomes low, and due to this the sweat from human body cannot get evaporated easily. So, they may feel uneasy and discomfort. Change in water and chloride metabolism. Due to high humidity, there will be a great loss of water from the body when there is excessive sweating. In humid condition, hot and humid condition, which is discomfort for worker, and in hot condition sweating is very high, and in humid condition this sweat cannot be evaporated, and evaporated is difficult or slow moving, causing workers to feel very uneasy. This can be maintained by drinking excess water, which may cause vomiting. Excessive loss may result in dehydration, and dehydration has its own problem. Now coming mental fatigue. Mental fatigue, this is due to continuous undersupply of blood to the brain. This is because of high humidity, and due to high humidity and high temperature, there is irritation in the mind, and the supply of blood gets reduced due to such condition, and this reduction in supply of blood causes the fatigue of brain and hence mental fatigue. A person suffering from this cannot judge the right condition inside the mind in his working condition. Whatever he works, he cannot judge in proper way. Now comes to fall of working efficiency. The working efficiency of a mine naturally falls with the increasing temperature and humidity of ambient air due to mental, physical fatigue and cramps in their muscles. So, these effects causes seriously the working condition of miners who works in the mine, and these are the some of numerical problems. What is the how heat can be generated? We can see that the 20.8% oxygen concentration enters mines and leaving 20.6%. In oxygen, how much consumed can be calculated, and due to this we can calculate the how much heat generated. And this is the another problem of calculation of vapor pressure, mixing ratio, relative humidity. Again numerical problem, you can calculate relative humidity, and these are the some references that has been taken into account to deliver the lecture. Thank you.